Deep, raspy, guttural gasps of a large animal, growing weaker. Distant, unsettling atmospheric drone.
Loud thud as the T-Rex hits the ground, followed by a low, mournful groan. What if the asteroid was just the final blow?
For decades, one story dominated. A cosmic impact. An extinction event.
A sudden, catastrophic end to an era.
But what if that narrative is incomplete? What if the stage was already set?
We imagine a thriving world. Dinosaurs at their peak.
But beneath the surface, cracks were forming.
Long before the asteroid, another force was awakening.
The fossil record tells a subtle, disturbing story. A story of decline.
Not of sudden impact, but of slow, insidious pressure.
Paleontologists discovered population drops well before the impact. Evidence of diminishing clutch sizes. Fewer, smaller eggs. Soft brush strokes, suggesting reproductive stress, a failing ability to propagate.
Faint pecking sounds, then a weak chirping.
And even the mighty predators showed signs. Unusual tooth wear.
Perhaps from consuming compromised vegetation, or changes in water chemistry.
To understand these subtle changes, we turn to the Earth itself.
Dr. Lena Petrova studies the very building blocks of the ancient world.
These layers record millennia of environmental shifts.
Is the Deccan Traps eruption, a scale of destruction almost unimaginable. The viscous flow incinerates everything in its path.
Look at this spike. The carbon dioxide levels are accelerating far beyond anything in the paleoclimate record. We have to address this immediately.
This data point represents a critical threshold. The sustained drop in biodiversity is unprecedented in the geological record.
We look down at this crater and see the end of an era. But what if it was also the beginning?
This small fragment tells us a great deal about the ecosystem during the late Cretaceous period. It suggests a much drier climate than previously thought.
As you can see here, the evidence of major volcanic activity and significant environmental shifts clearly predates the iridium layer impact.
These contours suggest a much older basalt flow than we anticipated.
Yes, but if we correlate it with the iridium spike, the data confirms it. We are sitting on the richest fossil bed in the basin. The next phase begins immediately.
We have a definitive match. The ice core samples show a sudden, massive release of volcanic ash precisely at the younger dryas boundary.